Hello, I'm Cheryl. In this problem, we're going to be looking for the absolute extrema of my function f of xy equals x squared minus 4xy plus 5. And I'm given some boundaries. I know that x has to be between 1 and 4 and that y has to be between 0 and 2. Now, absolute extrema can happen in one of two places. They can either happen at the relative extrema or they can also happen at boundary points. So we're going to need to look for both of them. So let's begin by looking for those relative extrema. Those are going to happen at the critical points. So let's go ahead and find some critical points. In order to find critical points, I need to find the first partial with respect to x. So I'll begin with the first partial, which is going to be 2x minus 4y. And then I also need the first partial with respect to y. So the first partial with respect to y is going to be a minus 4x. Now, for a critical point to exist, one of two things has to happen. Either both of these are 0 or one of them is undefined. Well, I can see that neither of them will be undefined, but let's see what happens when they equal 0. So if they equal 0, I have 2x minus 4y equals 0 and minus 4x equals 0. Well, if minus 4x equals 0, that means that x equals 0. And I can substitute that into my other equation and say 2 times 0 minus 4y equals 0, which is going to lead to y being equal to 0. So it looks like I have a critical point at 0, 0. Now, just because it's a critical point doesn't mean that I have a relative extrema. So I need to use my second partials test to figure out whether or not this critical point turns into a relative extrema. So what we're going to do is we're going to look at the second partial at the point 0, 0, and we'll multiply it by the second partial, again at 0, 0. Then we'll subtract the mixed partial at 0, 0 squared. So now I need the second partial. So let's see. I already have the first partial with respect to x up here. And if I take the second partial, I'm just going to get a 2. And it doesn't matter what I plug into the x and y, this value is always going to be a 2. Now let's take a look at the second partial with respect to y. Again, I'm going to treat x as a constant, so that partial is going to be 0. And it doesn't matter what I plug in for the x and the y. So I get 2 times 0. Now I'm going to subtract the mixed partial. So I'll start here with my first partial with respect to x, and I'll take the partial with respect to y. So I'm treating x like it's a constant. So this is going to be a minus 4. And it's always minus 4, no matter what point I plug in. So this is going to be a minus 4, and then I need to square it. So I'm left with 0 minus 16, which is a negative 16. Now, by the second partials test, I know that if this number is less than 0, which it definitely is, then I don't have a relative extrema. This is going to be a saddle point. So all this work tells me that I don't have an absolute extrema at any relative extrema. So now I need to check the second place where you can get absolute extremas, and that's at the boundaries. So let's take a look at what my boundaries are. I know that x has to be between 1 and 4. So it has to be between 1 and 4. I also know that y has to be between 0 and 2. So that takes me up to here. And what I've done, by using that information, I've created a rectangle that will act as my boundaries. So let's go ahead. I'm going to label each of these lines. We're going to call this one L1, L2, L3, and L4. And let's look to see what happens at each of these boundaries. So let's begin with L1. If I'm looking at L1, I notice that the y value always has to equal 0. So y is always 0. So my function is going to look like the function f of x 0. And that simplifies my function down to x squared minus 4 times x times 0, so that's 0, and a plus 5. All right, now I know what this looks like. It's a parabola. And I also know that my x values are going from 1 to 4. Now a parabola that is going to have a vertex of 0, 5 is going to be increasing on the interval from 1 to 4. So I'm only going to check out what happens at 1 and what happens at 4. And at 1, I'm going to get 1 squared plus 5, which is 6. And at f of 4, 0, I'm going to get 4 squared plus 5, which is 16 plus 5, or 21. So those are possible absolute extrema. But I've only checked one of my boundaries. So now I have to see what happens at L2. All right. So L2, when I look at L2, I notice that the x-coordinate of any point on L2 is always going to be 4. So I know that x is going to equal 4, which means that I can rewrite my function as f of 4y. Well, what does it look like? Well, then I'm going to have 4 squared, which is 16, minus 4 times 4 times y plus 5, which is going to be 16 plus 5, so that's 21, minus 16y. Okay, now 21 minus 16y is a line, and it's a line that decreases. So I know it will have its largest value when y is 0, and its smallest, when y equals 2. So let's go ahead and see what happens when y equals 0 and when y equals 2. So we have f of 4, 0 is going to be 21 minus 16 times 0, which is 0. So that's going to give me 21. Then we'll check out what happens at f of 4, 2, which is going to be 21 minus 16 times 2. So I'm going to have 21 minus 32, which is negative 11. All right, now I need to look at line 3. So let's go ahead and take a look at L3. If I look at L3, notice that the y value will always be equal to 2. So I can rewrite my function as f of x2. And now it's going to look like x squared minus 4 times x times 2 plus 5. So this reduces to x squared minus 8x plus 5. Now this particular curve is a parabola, and it happens to have its vertex when x equals 4. So remember, x is going between 1 and 4. So in a parabola, if the vertex is at 4, I'm going to be decreasing between 1 and 4. So that means the largest value is going to happen when x equals 1, the smallest when x equals 4. So let's check both of those out. So we're going to do f of the point 1, 2, and that's going to be 1 minus 8 plus 5, which is going to give me a negative 2. And I'll look at f of 4, 2, which is going to be 16 minus 8 times 4, which is 32, plus 5. So we're going to have 1 minus 11. All right, last piece of my boundary. I need to look at L4. So L4. Notice that the x value will always be 1. So I can rewrite my function as the function f of 1, y. So now it looks like 1 squared, which is 1, minus 4 times 1 times y plus 5, which reduces to 1 minus 4y plus 5, so that's actually 6 minus 4y. And again, I have a line, and I have a line that's decreasing. So its largest value is going to happen when y is 0, and the smallest when y is 2, because y bounces between 0 and 2. So let's see what happens. I'm going to have f of 1, 0. And so that's going to be 6 minus 0, which equals 6. And then I'm going to look at f of 1, 2, which is going to be 6 minus 4 times 2 is 8, which is a negative 2. All right, now what I need to do is look at all of my results. I have a 6, 21, 21, negative 11, negative 2, negative 11, 6, and minus 2. I need to pick out the largest value. The largest value is 21. So my absolute maximum is 21. So absolute max is 21. And it happens a couple of different places. It happens here, it happens here, and I guess those are the two places where the maximum occurs. So it happens at the point 4, 0. So this happens at 4, 0. And also, well, actually 4, 0, this is the same point. So it happens at 4, 0. Now let's go through it and look for the smallest number. The smallest number, as I look through, is going to be the negative 11. And again, it looks like it happens a couple of different places, but this is the 0.42, and that's also the 0.42. So the absolute minimum equals negative 11, and that happens at the point 4, 2. Now we're going to use a computer algebra system to confirm our result. If you take a look at your region and how it fits with f of x equals x squared minus 4xy plus 5, it looks like a rectangle that's been twisted. And you'll notice that the maximum point and the minimum point happen at the corners of that twisted rectangle. And you'll see that the maximum point happens when x is 4 and y is 0. And the minimum point happens when x is 4 and y is 2. So it confirms my result. I hope that was helpful. Thanks.